lecturing demonstration time for 10 minutes. Okay?
Okay.
Yes, because I want to make sure everything can be on schedule. So good afternoon everyone, my name is Jerry. So I'm in charge of the electrical circuit design this course. So I choose some concept for everyone. Because as you can see, this is a heat sink. The main function of heat sinks is to release the heat from some component. So for these components, it's quite easier to understand that that is the source to create the heat, just like a MOSFET. Yeah, MOSFET, yeah, something like that, or diode. Okay, so we put heat sink there, just try to reduce the heat from these key components. Okay, so this topic we'll talk about OTP, over temperature protection. So as you can see, I just list a key point here. It's a protection to shut down the power supply when the internal temperature exceeds a set value. Okay, so this is the heat source from the key components, and this is a heat sink. So we put a sensor here, but the sensor is another kind of component. I will explain these components later. But before I discuss the thermal protection components, I would like to give you some interaction about the design. Okay, so as you can see, this is a flyback converter. It might be a forward converter. Okay, this is a main topology, and this is the power management integrated circuit. So, of course, this is the output. So you can get 5 volt here, 3.3, 12 volt. So it can be used for like a motherboard or something. Okay, and so if you are the R&D engineer, you want to make an extra OTP function, over temperature function. So I can give you a component. So where is the best place that you can put the component? Take a guess. So far so good, everyone?
On top of the sink.
On the top of the sink. So
You mean the temperature sensor?
yes, and for this one, the classmate mentioned on the top of the heat sink, maybe here or here or here. But I think the best way is to try to close the components. But I think why the designer put the thermal sensor here is that it can be covered by the tube easier. Because if we put the sensor lower, maybe it can be removed quite easier. Okay, so I think that might be the design consideration. So how about a circuit? Which place will be the best place to put the OTP component, over temperature component? Take a guess. So I will give you some selection. Okay, let me check. Okay, so the first one is you can put the components here. Okay, or you can put the components at the VCC pin, or you can put the components in the PGI pin. Okay, so let me just tell you my suggestion. Okay, because the over temperature protection is trying to protect your circuit. So that means when the temperature reach to the OTP point, for example, if we set 85 degrees C and the component is very, very hot, reach higher than 85 degrees C, you need to shut down your power supply. But remember, the OTP is a protection function, and the component just like a sensor component, so it cannot withstand higher current or higher voltage. So you should put the components in the signal loop. Okay? Signal loop, that means you cannot put the sensor in the power source here. Maybe you can try some lower voltage, lower current rating pin of your IC. Okay? So if I were you, I will put the OTP sensor here. Because when the temperature higher than the setting point, the VCC just cut down. So the IC cannot work. But when the temperature goes down and the OTP sensor still working, then the VCC can be returned back. So the integrated circuit can work normally. Okay? So that is a function. This is a design consideration that show you some equation to tell you how to calculate the suitable value. But because I want to make the presentation on time, so you can refer the data by yourself. So this slide also give you some example. For example, here, if 70 degrees C is the setting point of your OTP temperature. Okay, so you can put all the resistor, and with the reference voltage, you can get the voltage divided resistor there, 2.2 kilo ohms. Okay? And by the way, they just give you some range of the OTP. Okay, so my wife. Also, I still have 3 minutes. So let's take a look about the key components of the thermostat. Actually, you can use the thermostat to achieve the OTP function. So as you can see, this is the appearance of different style of thermostat, like 85, 100, 85, 95. So you can choose what kind of temperature do you want. Okay, for example, if I want to choose 85 degrees C to let your circuit be open, so I will choose this one or this one. Okay, it's quite easier for user to choose. Okay, so this slide show you the physical concept of thermostat. So this is a description, but I will just explain by using the figure on your left hand side. As you can see, there are two different metals there, and this is a closed loop. That means if the thermostat working normally, so the current path will flow this way and flowing through the components and flowing back to the closed loop. So think about that way. If two metals combine together, one metal is getting hot, that means it will get, you may think about extension, right? Heat will make extension. Cold will be shrinking. Okay, I try to explain in English, but I think you know what I'm saying now. Okay, for example, if this one getting hot, the metal will be longer. This one will be shorter, so it will bend the metal like this. Therefore, this circuit will be like an open loop. Okay, so that is an easy concept for the thermostat, just like that. Okay, because just combined with two different metals, so this one and this one, because they are combined with two different metals. So when the temperature reach to the OTP point, it will bend to let the thermostat like an open circuit. Okay, but when the temperature turns back, okay, turns lower, it will reach to the original position. So your circuit can work again. Okay, I still have it.
1 minute.
No, I don't have. I got only 50 minutes. Sorry, 50 seconds. So this is a feedback converter. So as I mentioned, you may put the components here, because this is a very low voltage, very low current. So you can put the thermostat here, okay? But in other loop, the currents might be very high, so thermostat is not suitable for higher voltage or higher current loop. So this one will be the suitable point, okay? So that's my lecturing, yes, because I want to control for 10 minutes. Thank you. Yes, thank you.